All right, Hawk. So today we are putting together so many skills and solving polynomials. So a couple of reminders. The number of solutions equals the degree. So if our degree is 5, we should have 5 solutions. Solutions, x-intercepts, roots, and zeros are all asking for the same thing. Imaginary solutions have to come in pairs. Remember, an imaginary is from the square root of a negative, and when we square root, it's positive and negative. So it's always going to be like a plus 2i and a minus 2i. They're always going to come in pairs. So some tools that we have to use to help us solving is we can find the x-intercept on the graph. If you have lazy tendencies like me, I would probably check your graph first. It might save you some work. A bounce on your graph means that it has an even multiplicity. For math 3, that even multiplicity is just going to be a multiplicity of 2. A swivel has an odd multiplicity. And again, in math 3, that means it's going to be a multiplicity of 3. You can also find the zeros looking at the table. We would look for when y is 0. You could find the factors and set each of the factors equal to 0. You can use synthetic or long division. That should say division. That's a spelling error, sorry. And then one of the factors of solutions to break it down. Once you break it down to a quadratic, you can always use quadratic formula or the square root property. So again, that last one, quadratic formula and square root property, is only when it's a quadratic function. So if we look at number 1, and I'm going to kind of bounce between the board and the computer because you guys say it looks better on the board. This is a cubic. So right away on my paper, I would write that you have 3 solutions. As soon as you see this degree is 3, you can write x equals 3 times because you're not done until you find all 3 solutions. The first tool I said I would recommend you using is Desmos. So we're going to go into Desmos, just desmos.com. It's actually even better if you can use the North Carolina testing site, which is in our course. I can link it again to the top if that's helpful. But we have 4x cubed minus 12x squared minus 40x. And I just want to look at my graph here, and I actually see that it has x-intercepts at -2, 0, and 5. We did this one in class the other day, you might remember. So -2, 0, and 5, I can see all 3 solutions to my graph, so I don't have to do any algebra for this one. Of course, if I wanted to, you can factor, and you would take out a 4x and then factor it more. But I'm just going to show you one strategy for each of these. All right, let's look at number 2. So number 2 says f of x equals x cubed minus 2x squared minus 5x plus 10. Again, this is a cubic, so I know I'm looking for 3 solutions. I'm going to go and start with Desmos again. So let's just get rid of that 4, get rid of that 1, 2x minus 5 plus 10. Okay, then I'm going to hit enter to see it graph. So this time, I don't see any solutions here. So I can't see any zeros. I can see that it turns. It does hit somewhere, but I'm not really able to see this point. This point is nice. If I zoom in, so I'm just scrolling, it will show me that that one's exactly 2. I don't want to estimate, although technically, if it's multiple choice, you can match decimal to decimal. But for now, I just have x equals 2. So this is where the synthetic division comes in. So remember when we use synthetic division, we put our potential solution, and I do know that this is a solution. So I'm thinking if I asked you for a factor, remember the factor x minus 2 would have given you this. So I'm going to put 2 in the box, make sure I'm in standard form, 3, 2, 1, none, good to go. Take the coefficients. If you're confused with this synthetic division, that was yesterday's video, so you probably want to watch that. You're going to bring down the first one, 1 times 2, 2, that gives me 0, 0 times 2, 0, -5, -5 times 2, -10, 0. This needs to be 0 because it's a factor, so it goes in evenly. So now I have a cubic divided by this linear, so this one's just going to be 1 down, so that's going to be a squared. X squared plus 0x minus 5. So if I have a quadratic, I can use quadratic formula, or when b is 0, which it is in this case, remember A, B, C, when b is 0, it's actually, in my opinion, easier to just do the square root property. So this right now is really just saying x squared, no x, minus 5. So all I have to do is say, well, x squared minus 5 equals 0, add 5, and I get x squared equals 5. To get rid of that square, I'm going to square root. X is positive and negative square root 5. Whenever you square root, remember it gives you 2 solutions, well, unless you are square rooting as 0. So my other solutions are the square root of 5 and negative square root of 5. Of course, you could just write your solutions as x is 2 and x is positive negative square root 5 if you wanted to save some writing. All right, let's move on to number 3. Number 3 is another cubic. If you have been watching the honors section, you know how to factor this one. This one is a difference of cubes. But if you have not, we're going to use all of our skills, remember? So I'm just going to go ahead and put in x cubed, minus 64 into my graph. I'm going to hit this little home because that's going to bring me back to my 10 by 10 graph. It's actually a little bit more than that, but it is a 10 by 10. So I'm using my graph. I see one of my solutions right here. You can click on it just to make sure. So x is 4. I'm good to go with that. So I know there's going to be 2 more because that's 3. That tells me that there are 3 solutions. So I'm going to use this solution to divide out the other ones, but this one's a little wonky because if I put it in standard form, I'm missing my quadratic term and my linear term, my degree of 2, my degree of 1 here. So I need to put zeros there. All right, put the 4 in the box, your coefficients down, and then you bring down your first one, multiply, add, repeat, right? Multiply, add, repeat. This last one must be 0. You can't have a remainder if this is a factor. If you get a remainder, you did something wrong. All right, this is cubed, so I'm going to go down to x squared, then my linear, then my constant. So now here, I'm going to use quadratic formula. I can't use square root property because this linear term here, this b value, is going to make it mess up. You can't take the square root if there's a quadratic and a linear. So instead, I'm just going to use quadratic formula. Hopefully you all memorize that by now. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's a is 1, b is 4, c is 16. Notice I'm using the new one because I can't do quadratic if that degree is 3. So now I'm just going to simplify this. You always start with the discriminant, which is under the radical. So I get negative 4 plus or minus the square root of negative 48 over 2. Well, that negative in the square root tells me why I don't see any of the other solutions. And if I zoom out, you'll see it's not going to hit the x-axis anywhere else. The other change in direction's way down there. So that's kind of your hint that your other 2 solutions are imaginary. So let's break down this negative 48. The negative tells me there's going to be an I. Maybe we can do 4 and 12, 2 and 2, 4 and 3, 2 and 2. You're welcome to use any pair or your perfect squares. But here I have one group of 2, so that comes out. Another group of 2, that comes out. Each group comes out as 1. I is out. That's the square root of negative 1. I is the square root of negative 1. And then this 3 didn't get broken down. I hope I didn't cross it out. I didn't mean to. The 3 is kind of stuck in the house. So now I have negative 4 plus or minus 2 times I gives me 4i, square root 3 all over 2. Last step here is just to see if I can reduce anything. So they are all divisible by 2. So I divide everything by 2. which means I have negative 2 plus or minus 2i square root 3 over 1, which dividing by 1 isn't going to change it. You're welcome to leave it over 1, but dividing by 1 does not change anything. So negative 2 plus 2i square root 3, negative 2 minus 2i square root 3, or you could leave those two solutions combined with a plus or minus. All right, number 4. Let me just erase this board. Number 4 looks super confusing. First thing you should realize that is different about number 4 is that now our biggest degree is 4. So what does that tell you about your solutions? That means there's going to be 4 solutions here. So 1, 2, 3, 4. I'm pretty much going on a hunt for 4 solutions. All right. Give me a second so I can just put this in here. So we have x to the 4th plus 2x cubed minus 13x squared minus 14x plus 24. Okay, I'm going to go back to my little house and hit home. Oh, this is so nice because I can see 1, 2, 3, 4. I see all 4 solutions. So if I got too intimidated, I might not try that problem, but this one was actually really easy because all 4 solutions are right there on my x-axis. Solutions are x-intercepts. I could also look at the table on this one if I wanted to, and you would see negative 2 has a 0. 1 is a 0. So hopefully that helps you. Okay, that brings us to number 5. My voice is cracking. I have no idea why. X to the 4th minus 2x squared minus 8. If you've been watching honors videos, you do know how to factor this. You could factor this one. But again, for time's sake, because this is a crazy year, we are just going to see what our graph gives us. This is a quartic, so I should have 4 solutions here. Oh, bum, I only have 1, 2. So this time I know that I have 2 and negative 2, or negative 2 and 2. Technically, sometimes they like you to go from smallest to largest. We're not going to stress that right now. All right, so if I have 2 solutions, I know if I can get it down to quadratic, I have some other tools. So I'm just going to use the first one and do synthetic, and then my plan is to use the second one that I got from my graph and use synthetic again. So if I want to use synthetic, remember I need to put this in standard form, and every degree needs to be accounted for. So I need a 0 because there's no cubic, and a 0 because there's no linear. Then I put my solution in the box and my coefficients next to it. I'm going to go faster this time just because we've done a couple synthetic division already in this video. So your remainder is 0. I'm at a quartic, so now this answer that I'm getting is going to be a cubic, 1 degree less. I'm going to take this one and my other solution that I got from the graph, and it wouldn't have mattered if I would have started with this one and then did this one. At the end, I'm going to get the same quadratic. So if you have 12 and you divide by 3 and you get 4, and then you divide by 4 and you get 1, that's going to give you the same thing as if you had 12 and you divide by 4 and get 3, and then divide by 3 and get 1. The order you divide these solutions doesn't matter. Okay, so here are my coefficients. Bring down your first one, 1 times negative 2. All right, perfect. I have this 0 again. So this time I was at a cubic. I took 1 away, so now this is a quadratic, 0x plus 2. Yay, I don't have a b. I like these better. Quadratic formula is just a little too tedious. And if I don't have a b, that means I can use square root property. So to use square root property, get the square root by itself. X squared equals negative 2. Take the square root. So x is a negative, means an I is going to come out. Positive and negative, I square root 2, because I can't break down that square root of 2. That's a prime. So I have I square root 2 and negative I square root 2. So I might have seen this answer as x equals positive and negative I square root 2 and x equals positive and negative 2. That would work as well. Okay, last one is number 6, and I'm actually going to go back to the worksheet for this one so that y'all can see the graph. And I'm going to play with it and just make it bigger for a second. So if we look at the graph, we are going to talk about end behavior again. We talked about it briefly in Unit 1, but here's what I'm talking about when I talk about a bounce and a swivel. So this one kind of goes like this, and then it goes up and down. I was not an art teacher on purpose, so please don't judge my art. But right here, you see how this comes up and goes right back down? It changes direction once. So direction change plus 1 gives you the degree or the multiplicity. So this x equals negative 1, that's a bounce. Imagine it like going up, hitting the ceiling, and coming back down. So there's a multiplicity of 2. Those of you going on to calculus eventually, just know that it's an even multiplicity. For Math 3, we just do multiplicities of 2 and 3 when we're looking at graphs. All right, this one, something wonky is happening too. It kind of looks like a slide or a swivel. So this one, if I zoomed way in, this would go up, down, and back up. So it actually changes direction twice. So direction change plus 1 equals the degree. So this at x equals 2 actually has a multiplicity of 3 because it goes up, down, up. So it changes direction twice, plus 1 makes it 3. It's odd greater than 1. This one at 4 is just a straight pass through, so that's no multiplicity. That would give me x is 4. So this one should have 1, 2, 3, 4, 5, 6. Again, there's 2 here, 3 here, and 1 would make this a degree of 6. Okay, so that would be a degree of 6. There's 6 solutions for this crazy graph. Don't get overwhelmed. We're going to work on this together. Good luck.